So first week is just introduction. So hopefully we can end today's class early. Starting this Thursday, we will begin the practice session. But which will also be a relatively an easy practice session for the first week. All right, so welcome to AI504 programming for artificial intelligence. 프로그래밍 for AI를 위한 인공지능을 위한 프로그래밍에 오신 거를 환영합니다. Right, so today is just introductory material, so no pressure. So what is AI? So I always start with a definition of AI and definition of machine learning and deep learning and so on and so forth. So if you're already familiar with all these concepts, just please bear with me. This, of course, is actually for those who barely know machine learning. And the prerequisite is that you know how to do Python. You know how to write codes in Python. And the recommended prerequisite is that you have already taken a undergrad machine learning course. But if not, that's also fine. So let's begin. So what is AI? So AI is any effort that tries to make machines or computer, emulate or mimic human intelligence. So it's a very broad concept, and it is a concept as old as the computer, because Alan Turing, when he made the computer itself, also thought about an automatic machine that can play chess with people. So that's already chess playing machine. The concept is as old as 70 years ago or something, 1950s or 1960s or something like that. All right, first of all, I'm gonna just mute everybody. Although if you have questions, you can just type, or you can speak whenever you want. I'd like to keep this the entire course pretty much very interactive as much as possible. So any question is always welcome. All right, so AI is like the superset, and then there's within the field of AI there's something called machine learning. So it means that there are other subfields of AI other than machine learning. So but machine learning specifically is any effort that uses statistical methods to teach machines to learn from data to be good at a specific task. So you need data to do machine learning. That means so it's a pattern recognition based learning. Could we download the PPT? I'll actually talk about that at the end of the session today. So please, spoiler is that all the videos and all the material will be uploaded on a website called Classum. I'll also talk about it. Right, so machine learning is a subfield, and then within machine learning, there's deep learning. So machine learning has been around for, I would say, 40 years, maybe 40, 30 years. So typical machine learning that we know, such as logistic regression. Logistic regression is actually more of a statistical tool, like it's a statistical analysis tool rather than a machine learning model. But come 90s, so 1995, SVM was developed, and I would say SVM is a proper machine learning model. So starting with the around 1990s, like mid 90s and late 90s, machine learning actually took place, and then it performed a lot of useful tasks for us, such as spam filtering. Spam filtering is a very well-defined binary classification task. Given an email, is it a ham or a spam? So starting in the late 90s, people were already, whether you know or don't know the users, they were already in the experiencing the power of machine learning. And come 2012, so that's probably the birth, that is the year when deep learning was born. So deep learning within machine learning, there's a lot of subfields, but subfields or groups of models that people like to use, and the deep learning is one of them. So deep learning is training machines to be good at complex tasks. So rather than spam filtering, which is a relatively easy task, complex tasks is like translation or image captioning or style transfer, that kind of stuff. So training machines to be good at complex tasks based on neural networks. So that is the important part. It mostly relies on neural networks and massive data. So so these two became, so there are three things that are different from machine learning. It's complex task, neural network, and massive data, but it's still using data. So that is why it's a subfield of machine learning. So this is like the hierarchy of AI, machine ML, and DL. Right. So why deep learning? So why out of all the machine learning subfields, SVM, like clustering and all those, why deep learning? Since you can see that since 2012, that is when AlexNet was born. So before that, prior to 2012, the best model to do the best model in ImageNet challenge. So I hope everybody knows what ImageNet is. ImageNet is a massive, like 1 million samples of images. And the challenge is, or the task is, that you have to classify the given image into one of 1,000 classes. So prior to 2012, the best model achieved 73% accuracy. This is error. Actually, there's no axis label. So this is actually error. So 26% error means 73% accuracy. 74% accuracy. So this is 74% here. Then 2012 AlexNet came, and then just 10% increase in accuracy all of a sudden. And then after that, it just exploded. We reached the upper bound of ImageNet challenge pretty quick within 3 years. So 2012, 2013, 14, 2015, 2016. 2015 is the era of ResNet. And you can see that the people usually perform at 95% accuracy, and ResNet performs at 96.4, which is superhuman. So, the ceiling was reached pretty quick. And this is all thanks to deep learning. So this is why deep learning was so much, was so popular, so attractive, and so powerful. It's the pure performance. It just showed performance that was thought to be impossible before. So that is one. And another reason that deep learning is so popular is that less feature engineering. So prior to deep learning, people, if you wanted to make a dog classifier, or like an image classifier, for example, then you would have to think about the characteristic of the object that you want to classify. For example, if you want to classify a dog, you want to build a model that classifies as a given image into a dog or something else, like dog or no dog, then you would have to, as a human, you have to think of all the properties of a dog and then put that into a machine. For example, like, does it have eyes? Does it have furs? What is the color? Like, does it have nose or ears? Whatever. Like the element of dogs. Then you code that. You write that in code, so that the machines can learn. Machines can focus on those features to figure out whether a given image is a dog or not. So that is a typical process in developing machine learning models before deep learning. And this would apply not just to image classification, but to any machine learning task. Like if you want to do like a spam filtering, then you would have to think about what kind of emails are to be classified as spam. So you have to think about the words and the frequencies of the words and all those kind of things, and then put that as a feature. So that is why prior to deep learning, people usually stayed in one area. So computer vision experts are called computer vision experts because you need to think about all those things that are specific to images. NLP experts just stay to be NLP experts because you had to have a linguistic domain knowledge to properly develop a machine learning model, and so on and so forth. But these days, people just do whatever they want. So at one time they work on computer vision task, and another time they work on NLP task, and the other time they work on something else, like audio processing or healthcare or whatever. So these days, the barrier between the subdomains have been, I would say, significantly lessened because of this property of deep learning, less feature engineering. So these days you just have, but if you have enough volume of data, then you just put that into a model, into the machine, and then the machine will perform feature extraction and the task at the same time. So it serves both purposes. So I would say it's a democratization of machine learning. You no longer need, like very, very deep domain knowledge to do anything. You just need to write code. You just need to know how to write codes in PyTorch, and you just need to have a lot of data. And then the rest of the task will be taken care of by PyTorch or TensorFlow. Right. And the third is, the large data. So in order to actually, the reason that people no longer need to do feature extraction by themselves and let the machine take care of it is because there are a lot of data. You need to put really a large amount of data in order for the neural networks to figure out the features by themselves. And this is relatively easy to get, especially in these days because of all the internet. So large data is all possible by social network services like YouTube, Instagram, Twitter, Google, Wikipedia, news articles, because people just upload their data for free. You upload your selfies in Instagram, selfies on Facebook, you upload your videos on YouTube for free, and then the Google and Twitter, you just write stuff on Twitter because you have something to say. It's all free, and the companies are just collecting your data for free, and they're using it for machine learning. So it's pretty good. It's a pretty good time for IT companies to develop like very, very large models, and then show state-of-the-art performance. Right, and paired with the large data, you need to actually have a powerful machine. The reason that deep learning didn't work before 2012 is the lack of these two factors, large data and powerful machines. I mean, even before 2012, World Wide Web, when internet was already around in the internet was experiencing a very explosive growth in I would say, in the 2000s, early 2000s. That was when the dot-com bubble burst, actually. So internet was around. That means that data was already available, but this was missing, the powerful machines to actually train a large neural network. So in order for you to achieve state-of-the-art performance and no feature engineering, is that you need to have a large data and powerful machines at the same time. So before AlexNet came about in 2012, people didn't know how to train. Well, actually, people had idea, but there was not an actual real implementation of a trainable large neural networks. And GPU came along, and Alex Khrushchevsky, who was the author of AlexNet, wrote CUDA codes by himself, and then showed how to train a large neural network with a GPU card, a hardware that was developed for computer games, actually. And then after that, people knew how to train neural networks with a very powerful GPUs, and even TPUs came about. So these days, training a large model is completely it's a mundane task. Anybody can do it. So these two, so large data and powerful machines, you still need these two. If you're interested in doing deep learning, you definitely need these two. But if you're just doing classical machine learning, like support vector machines or trees or that kind of stuff, then you don't need these two. Actually, you just need some amount of data for the machines to figure out the patterns, and you just need good CPUs. Right, so modern AI can do a lot of interesting, weird tasks, beating people in Go. Style transfers, you can see that the photo is being transferred into different styles. This is Edvard Munch's style. This is someone else's style. Translation, image recognition. It's all something that was thought to some tasks that were thought to be impossible, even I would say 10 years ago or 20 years ago. Definitely nobody thought this would be possible. Question: is there a CUDA GPU programming included in this or other course? Here, no. In this course, you just learn how to write codes in PyTorch, and the rest of the actual CUDA programming will be taken care of by PyTorch underneath the hood. But you can actually, since PyTorch is an open source project, you can just read PyTorch codes and learn how the inner workings of PyTorch, how the CUDA codes are written underneath. But here in this course, no, we don't talk about CUDA programming. Right, so this was, I would say, this is pretty standard in this deep learning era. And then after that, that since based on these, you know that what can be, you know that if you have almost infinite computer, very, very, very powerful hardware like GPUs or TPUs, like thousands or maybe tens of thousands of them. And if you have almost infinite data, then you can do whatever you want. So GPT-3, which came about in, I would say, was it last year? Yeah, it's last year, right? So GPT-3 came in 2021, and it is a good proof of this concept. If you have a lot of data, and if you have just infinite compute resources, then you can just demonstrate magical stuff. So in developing GPT-3, people estimate that they probably use more than 1,000 GPU cards, and the amount of data the sheer volume of data is 570 gigabytes of text, which means that just anything readable from the internet, they just downloaded it. So that in tokens, token means words, in tokens, the count is 400 billion, which is how much? It's 4천억 정도 되는 4천억 토큰이니까 이제 하여튼 인터넷에 있는 거의 웬만한 문서를 다 긁었다 이렇게 보시면 됩니다. So if you combine the two, then the GPT-3 is born, which has 175 billion parameters. So that's 1,750억 파라미터죠. And training this model probably took more than $4 or $5 million for paying the electricity bill. 그러니까 이제 전기세가 이제 한 50억, 60억, 뭐 어디서는 100억이라고 추산하던데, 하여튼 전기세도 어마어마하죠. 이제 이런 것들이 이제 가능하다. 이제 하여튼 무식하게 많은 데이터와 무식하게 많은 하드웨어가 있으면은 이제 무식하게 많은 전기세를 써가지고 이런 큰 모델을 만들 수 있는데, 이제 이런 모델이 뭘 할 수 있냐? So what kind of things that does like models such as GPT-3 do with all these GPUs thrown at it, all the data and all the electricity bill thrown at it? What can it do? So GPT-3 consists of 96 layers of transformers. So 96 layer means, so that is why 175 billion parameter. 96 layers of transformer. And if you are familiar with BERT only uses 24 layers. So this is like 4 times more than that. And so GPT-3 can do a lot of things. Anything linguistic, it can basically just do. You can just, let's put it at that. It can do question answering. It can do translation. It can just write anything that you want it to write, such as like a news article here. So this is just one example. So the gray text is it's a prompt. It's an input given by the human. So the human wants the machine, the GPT-3, to write something, some newspaper article with the title "United Methodists Agreed to a Historic Split," which means that 이제 미국의 감리교가 이제 역사적으로 큰 그 분열을 했다. 이제 서로 종파가 갈라진다. 뭐 이런 거고요. Subtitle is "Those who oppose gay marriage will form their own denomination." 이제 그 동성 결혼을 그 반대하는 쪽 그룹이 있겠죠. 감리교 내에도 이제 그래서 걔네들은 이제 자기네 오운 종파 denomination이니까 이제 그 종파를 그냥 따로 이제 딴지 세살 차리겠다 뭐 그런 거고요. 근데 여기서부터가 이제 여기서 이만큼이 이제 이 머신이 쓴 건데, GPT-3 모델이 쓴 건데, 혹시 뭐 잠깐 읽어보시면 굉장히 이제 아주 그 고품질의 텍스트를 썼다는 걸 아실 수가 있습니다. So if you read the black text here, you can see that it completely aligns with the title and the subtitle given by the people, given by the human user, and it is very, very consistent and very high quality. So you can see like words such as LGBTQ, which means that the machine has understood what gay marriage is, and it has something to do with LGBTQ, all the yada yada. I won't read the entire text, but if you have, I'm gonna upload it, and I'm gonna upload this slide. If you're interested, you can read and then just be impressed by what GPT-3 can do. I would say this is the writing skill of GPT-3 is at par with I would say at least high school students. And this is some game that GPT-3 can play. It's define and demonstrate. So the game goes like this. So you define a word, you come up with a word that does not exist in the English dictionary, and you define what it means, and then you use it in a sentence as a demonstration. For example, here, this is human written. So a watpu doesn't exist, right? So watpu is a small furry animal native to Tanzania. An example of a sentence that uses the word wapu is, we were traveling in Africa and we saw these very cute wapus. All right, I'm gonna mute everybody. So this is a demonstration given by the people, and then it's the GPT-3's turn to play this game. So to do a fardal, so human, again, defines a new word that doesn't exist in the dictionary. So to do a fardal means to jump up and down really fast. An example of a sentence that uses the word fardal is, and then it's the model's turn to actually use it in a sentence by understanding what fardal is. So, and then the machine wrote, one day when I was playing tag with my little sister, she got really excited and she started doing these crazy fardaddles. Completely perfect example. You know, so 그 파더들이 이제 그냥 사람이 정의를 한 거예요. 파더들은 그냥 굉장히 빨리 이제 그 점프를 뛰는 거다, 막 날뛰는 거다라고 정의를 하고 이제 그거를 기계한테 자 이제 네가 그거를 문장에다 자연스럽게 한번 써봐라 했더니 이제 내가 그 여동생이랑 그 술래잡기를 하고 있었는데 흥분을 하더니 father를 하기 시작했다. 그러니까 완전히 이해를 했다는 거죠. 그리고 그 example도 perfectly okay 하는 거죠. Just one more example. I like this example a lot. A yalubalu is a type of vegetable that looks like a big pumpkin. An example of a sentence that uses the word yalubalu is. 그러니까 이제 야루발루라는 존재하지 않는 단어에 대해서 정의를 했을 때 이게 이제 그 큰 호박과 비슷하게 생긴 어떤 야채다. 뭐 야채죠. 야채다라고 정의를 하고 이제 네가 써봐 했더니 I was on a trip to Africa and I tried this yalubalu vegetable that was grown in the garden there. It was delicious. 이것도 당연히 이제 굉장히 잘 맞고 있죠. So completely aligning with the definition of yalubalu. But the reason that I like this example so much is that yalubalu feels like an African word. Like if you remember 2012 World Cup, the term that vuvuzela, you know, it was a tool that they used to make noise. So 그러니까 부부젤라 뭐 이런 그 단어를 생각하면 얄루발루도 왠지 그 아프리카 뭐 스와힐리어나 뭐 이런 거일 것 같지 않아요? 아프리칸 어일 것 같잖아요. 그래서 얘가 아프리카를 썼나 여기다가. 그러니까 여기는 이제 아무런 아프리카라는 단서가 없는데 얘가 이제 굳이 이 모델이 내가 아프리카 가서 이 얄루발루를 먹었다라고 한 걸 보면은 얄루발루가 왠지 그 아프리카 냄새가 나서 그런 게 아닐까라고 저는 이제 한번 상상을 해보거든요. 왠지 그럴 것 같은데 그래서 저는 이제 이게 정말 훌륭한 모델이다 이렇게 생각을 합니다. So amazing things can be done with GPT-3, and it's not just GPT-3. Modern deep learning models from large companies such as OpenAI and Google, they can do amazing stuff. So DALL-E 2, I'm not sure how to pronounce this. I would say Imagine, and Party. There's instead of Y, this is I. So all these are text conditioned image generators, a conditional text to image generator. So given a blob of text, the machine has to draw a picture that aligns with the given text semantically. And DALL-E 2, Imagine, Party, they either use transformer or diffusion. So for the first two uses a combination of transformer and diffusion. Party uses just only transformer, and so this is DALL-E 2, this is Imagine, this is Party, and you can see that the quality of writing is just phenomenal. So an astronaut riding a horse in a photorealistic style. So this is the conditional text given to so this is a human input to the model, and then the model has to understand the sentence and then draw. And you can see the quality of the drawing is just out of this world. People cannot draw this. Normal people, you have to be at least a professional painter or a student at a drawing school. At least you have to be an expert in that field. This again, a chrome-plated duck with a golden beak arguing with a golden turtle in a forest. You can see that the texture of chrome, it means that the machine has this is from Imagine. So Imagine has understood what chrome-plated means, and of course so duck has to be chrome-plated. You can see the metallic texture here with a golden beak, golden turtle, arguing. Everything is just perfect, in a forest. And it knows how to out-focus. So here, they are, the two objects are in focus, and the background forest is out of focus. This is if you would, if you presented this photo to a person who doesn't know the existence of Imagine, and just tell them that this is an actual photo that you have taken in a forest with all these gadgets and tools and objects, they would believe it. This is as real as it gets. The last one is party. So a photo of an Athenian vase with a painting of a pangolins playing basketball in the style of Egyptian hieroglyphics. So these are very, very complex words, but just perfect execution. If you just came upon this image on the internet, you would believe that this is an actual vase in a museum somewhere. Like it's like a real thing in this real world. It's just weird with just weird, weird picture, weird drawing in it. So the shade, the brightness here, the dark area here, the texture, the hieroglyphics, the patterns here, the shadow of the vase behind the vase itself on the wall. Everything is just, you can't teach this stuff. This again, this is a drawing. This is an image that Party drew. So if you visit their websites, DALL-E 2, Imagine Party, you would be blown away by the quality of the image that was drawn by the deep learning models. Interestingly, well, we're going to talk about it, but interestingly, they require less number of parameters than GPT-3. So this guy has like 96 layers of transform. I think this DALL-E 1 used 48 layers or something. So image text to image actually requires less parameters than pure NLP models. Interesting. All right, so other fields, AlphaFold 2 also came about last year, and it's an achievement. It's an achievement by DeepMind, and what it does is predicts protein structure. So protein structure prediction has been a task well known, and it's been around for at least decades and decades. So what it does is that given a sequence of amino acids, you want to predict the 3D structure of the given protein. So protein consists of amino acids. It's a chain of amino acids, but it's not just one-dimensional chain. It forms. You can see that it forms a three-dimensional structure because of all the electromagnetic forces between the amino acids. So it's sometimes it forms like helix, sometimes it forms a plate. 그러니까 이제 판도 만들고 막 이제 막 그 꼬이기도 하고 나선형을 꼬이기도 하고 막 그러잖아요, 단백질이. 그래서 이제 이제 아미노 단백질의 구조를 알려면 옛날에는 막 그걸 이제 엑스레이 회절을 찍고 뭐 그래가지고 막 분석을 하고 막 그랬어야 되는데, 그게 아니라 이제 아미노산 서열만 알면은 이 아미노산 서열은 알기가 쉽거든요. 그냥 단백질 분석해보면 아미노산 서열은 쭉 나오니까 그것만 딱 보고서 3차원 구조를 예측할 수 있으면은 굉장히 많은 일을 할 수 있겠죠. 뭐 항원항체 인터랙션을 모델링 한다던가, 약을 만든다던가, 뭐 병원균의 구조를 파악한다던가 이런 걸 할 수 있는데, 이제 그게 기존은 어려웠는데, 이제 그 알파폴드 2가 나오면서 거의 아주 막 몇 옹스트롬 차이로 구조를 맞추기 시작해가지고 이제 거의 풀린 문제다 이렇게 보고 있습니다. So the task is that trying to predict the 3D coordinates of the amino acids or element of atoms of a given protein, and the AlphaFold 2 can predict within the error margin of like few angstroms. Angstrom is like 10 to the minus something, so it means that it's almost perfect. And it uses 48 layers of evoformer. Evoformer is just some variant of transformer that is mixed with domain knowledge, such as like biomedical or biological, biochemical domain knowledge. So all these were, I've talked about like transformers a lot. Like this is transformer, this is transformer, this is transformer. So transformer consists of like layers of repeated architecture, and we'll learn about it during the class this semester. Probably it's in like 10th or 11th class. And the hope is that if you follow this course very, very carefully with all the practice sessions, then you will be able to at least write codes for this or this or this. You won't be able to train because you don't, like, training takes a lot of money. And you don't have like 1,000 v100s, and you don't have infinite amount of data, but at least you'll be able to write codes for GPT-3 and DALL-E and this, so that if you have money, resources, then you can train it. So this is the goal of this. That is the goal of this course, trying to understand what's going on behind the scene, and then writing codes and trying to reproduce the paper, if possible. Right. So as I said, the goal is to learn to build deep learning models so that you can replicate papers, realize your ideas, and conduct AI research. So in order to do AI research, or specifically deep learning research, you need to implement your ideas and replicate other people's work as well. So the goal is to help you do that, of course, for everybody. All right, so this course as written here, this course teaches only the very basics, the like really, really simple stuff, you know. So in order to actually conduct AI research with high efficiency, you need to practice on yourself. So practice makes perfect. Right, the structure of this course is, I've already written this down in the syllabus, but just to recap, every Monday, there will be a lecture for teaching individual models for every week. You know, the contents is right here. Yeah, okay. So lecture on Tuesday, which will be done by myself, and then practice on Thursday. So you write or you implement what you've learned in Tuesday. Okay, so you write codes on Thursday based on what you've learned in Tuesday, and it'll be conducted by the TA. The first 2 weeks I'll be doing it, and then after that, the TAs will do it. There are only 2 assignments, Project 1 and Project 2. Project 1 is image synthesis using GAN. Project 2 is French-English translation using transformers. I would say it's a relatively easy tasks. And the grading will be letter grade, and Project 1 45%, Project 2 40%, attendance 10%. The first week, no attendance check. The attendance check will be done next week. Right, so the weekly plans are like this. So the first week, this is intro, and then this Thursday, we'll talk about NumPy. So NumPy is, if you're familiar with MATLAB, then NumPy is exactly like that. It's just MATLAB in Python, or R. And if you're familiar with R, if you're from statistical background, then you should be familiar with R. And then you can think of NumPy as R in Python as well. Like it's like MATLAB or R in Python, and it's free as opposed to MATLAB. And then the second week, we'll be talking about basic machine learning, and then scikit-learn, and then yada, yada. Like third week, PyTorch intro, autoencoders, VAE, GANs, ConvNet. Then comes project number 1, and then word embeddings and subword embeddings, RNNs, transformer on the 11th week. Then BERT and GPT. 13th week is multimodal learning, image text. 14th week is something called DDPM, Deep Diffusion Probabilistic Model. So this is the only thing that's different from the last year's AI504. Last year, AI504, we had neural processes, but instead of that, we were learning DDPM. So because of all the fiasco with all the hype with DALL-E 2 and Imagine, these two are DDPM-based models. So this semester, we're learning DDPM instead. And then 15th week, graph neural networks, and then the final week is project 2. So that will wrap up this entire semester. All right, so materials and discussion. So there's no textbook here. I'll always upload the materials prior to the course on Classum. So Classum is a web platform where you can this serves the exact purposes of operating a course over a semester. And please, so all the future materials, future videos, the codes, the materials for the practice sessions, it'll always uploaded on Classum. So you have to please join Classum using this link here. So this code is important. So copy paste this code, copy paste this link, and then run it on your browser, Chrome or Safari or wherever, and then join as a student. Then we can talk on Classum. And it's not just the uploading materials and sharing codes and videos. You can actually ask questions anytime you want. You can talk among yourselves between the participants. It's just an open platform. So again, please join Classum. So Expectation lecture. So you are expected to attend, and then the project is individual effort. There's no team. It's not team effort. You don't have to form a team. It's a relatively easy task, so you should be able to do it on your own. Deliverables will be the linked. The project number 1 is GAN, and project number 2 is transformer, right? So link to the model weights, and your model will be evaluated automatically. So it's project number 1 will be evaluated based on FID score. Project 2 will be evaluated based on blue score, and we'll talk about it as well. If you're not familiar with this, it's also cool. And since this course is taken, 300 people are taking this course, claims won't be taken on the principle. Like if you were sick, then that's a different problem. But if you made a typo, if you didn't follow the format, if you didn't zip your files correctly, it's all no. It's no for that. Because we are running this course, we're maintaining this course as a community service. There are a lot of people in KAIST who wants to take this course and learn how to do AI research, right? So that is why I'm taking 300 people at a time. So you are not, don't expect us meaning me, the lecturer, and the TAs, don't expect us to, carry your, provide care on the individual level. There are 300 people, and if 300 people have, claims, that's not going to happen. It's not going to fly. So please, on the project side, we're going to provide a format and the skeleton codes and all that. So please follow that and then stick to the format so that you don't waste my time or the TA's time, and then you get properly evaluated fairly, So question? Oh, somebody just copy pasted the code. Okay, that's fine. Is there a plan to connect KLMS and Classroom? Actually, no. Everything will be just on Classroom. KLMS is for submitting your projects. I'll be posting some important stuff on the first week on KLMS in case people missed this class today. But after next week, everything will be on Classroom. Right. Are you planning not to hold online lecture? This is online lecture. I'm not sure what you're asking. Every time it'll be just online lecture. Offline lecture, probably no. 300 people. Last time I held an offline lecture in Seongnam, in the Seongnam office, only 2 people came, and I just thought, what's the meaning of that? But yeah, if people are interested in holding offline lecture, I can definitely provide it. But if people just prefer to do it completely online, that's also fine by me. We'll talk about it as we go. 다시 한글로 말씀을 드리면은 이게 아주 중요하니까, 이게 300명을 지금 300분이 듣고 계시기 때문에 우리가 하나하나씩 다 맞춰드릴 수가 없거든요. 지금 TA가 4명밖에 없고 저도 이제 1명, 그러니까 총 5명밖에 없는데, 그러니까 300명이랑 TA를 막 10명씩 주는 게 아니거든요. 그렇기 때문에 이 프로젝트를 함에 있어서 우리가 드리는 그 스켈레톤 코드가 있을 거예요. 그 템플릿인데 그 템플릿을 맞춰가지고 제출하셔야 됩니다. 안 그러면은 이제 무슨 압축이 잘못됐다거나 오타가 났다거나 이런 거는 다 우리가 받을 수가 없습니다. 그냥 그런 건 다 그냥 감점 처리입니다. 그러니까 이 수업을 300명한테 제공하는 이유가 이거에 도움을 받고 싶은 분이 많다고 생각을 하기 때문이고, 실제로 많은 분들이 듣고 계시기도 하고 그래서 하는 거지, 이거를 저희가 다 300명을 그렇기 때문에 맞춰드릴 수가 없어요. 그래서 나중에 숙제를 하실 때, 프로젝트를 하실 때 철저하게 저희가 드리는 포맷에 따라서 하셔야지 문제가 없습니다. 근데 예외적인 상황 제외하고 누가 아프다거나 이런 거는 제외하고. 그렇습니다. Is grading relative? No, I've never done relative grading. All right, so the teaching team. Yeah, okay. Questions? I mean, if Classroom is connected in Calendars webpage, we can go to Classroom link easily by Calendars. I can upload it. I can post a notice in Calendars which contains the link to Classroom, if that will help. I'm not sure if there's like a feature in Calendars with link to Classroom. I'll look it up. Alright, so 그러니까 이제 그 클래스업 링크를 그 KLMS의 포스팅으로 공지로 남길 테니까 그걸 보고 오시면 됩니다. All right, so I'll just keep moving on. So the teaching team is myself. If you're interested if you're curious about myself, if you're curious about me, you can just come to this webpage. And the TA team is actually it's fixed. I'll actually update this. There are 4 teaching teams, and the head TA will be 경훈 her, but I'm not 경훈 허경훈님이 지금 들어와 계시나 모르겠네요. We'll also announce that in classroom as well. All right, so who am I to teach this this course? So I'm my question before I introduce myself. Question. Okay, it's a direct message, so that's fine. And another question to me is every lecture recording uploading on class? Yes, every lecture video and all the practice session videos, all the codes from the practice session, it'll all be uploaded in Classroom. So if you miss the class, then you can just, review the material and then just learn on your own. Actually, anybody who were unlucky, there's no use in saying this, but anybody so if you have friends, so all the people here, if you have friends who wanted to take this course, but, was blocked by the 300 limit, you can tell them to visit the Classroom page and then just, learn on themselves. Anybody can learn on their own time. I'm just uploading everything that is required to learn PyTorch over the entire course. So if you have friends or, anybody who you want to recommend this class, then you can just point them towards Classroom, and then they can just freely attend to the they can't attend, but they can listen to the lecture after the video is uploaded. So please keep that in mind. So my name is Edward Choi, and then my research area is usually in healthcare, NLP, and multimodal learning. And actually, if you read this, my thesis was deep learning models for electronic health records. Electronic health records is data collected by the hospital. 그러니까 한국말로 전자의무기록이라고 하는데, 이제 병원에 가서 환자들이 겪는 모든 행위들이 다 이제 DB에 저장이 되는데, 그걸 보고서 이제 여러 가지 행위를 할 수가 있습니다. And prior to coming to KAIST, I actually was a software engineer in Google Brain and Google Health, and I also did the same stuff, developing predictive models for electronic health records or healthcare models. So with electronic health records, you can do a lot of interesting stuff. Interpretable prediction. 그러니까 이제 뭐 미래에 너가 어떤 질병이 걸릴 거다 이런 걸 예측하면서 뭔가 이제 rational 뭔가 해설을 해준다든지 아니면 뭐 이제 or synthesizing healthcare data. So healthcare data is protected by the law because of its privacy issues. You don't want your hospital records to be spilling out to the world. If you have some specific disease or like something that could harm you in some way, like sexually transmitted disease or like terminal disease. And if insurance companies know that, then it'll be very bad for you. So healthcare data is usually very heavily protected by the law. So some people rather choose to synthesize them and share the synthetic data instead of real data. So we can also do this. You can do question answering on EHR, for example. If you can think about an AI speaker in the hospital, so that the patients or the doctors can consult to the speaker and then do diagnosis and whatnot. Multimodal learning is also a good subfield of healthcare, especially in electronic health records. You can have, there are a lot of multimodal data. There's like MRI scans, CT scans, X-ray scans. Those are images. Then there's EKGs and EEGs, 심전도나 뭐 뇌파 이런 것들도 있죠. Those are time series data. And then you have text from 이제 의사 소견서 같은 건 이제 free text 노트가 될 테고요. 그리고 이제 뭐 DB 같은 건 정형화된 데이터고. So there are a lot of different modalities for a single person. So it's a perfect place to do multimodal learning. Right. So I do these kind of stuff. Right. If you're interested in my research and further research in healthcare, you can visit my website here, or you can just send me an email and then we can have a meeting. We can just talk about general healthcare research. Right. Before we end the class today, so first assignment, it's not an assignment, but it's just recommendation. So all practice sessions every Thursday, all practice sessions will be conducted on something called Google Colab. So so if you're already familiar with Python notebook, Jupyter notebook, you can think of Google Colab as a notebook on the web. So you can use your Chrome browser and then connect to Google Colab, and then you can just write Python codes, execute, and then it'll just happen in your browser. Well, actually, the actual execution will be done by Google's cloud computing, but you can do it. You can access it via the Google Chrome browser, and not only Python, but you can also train PyTorch and TensorFlow models on Google Colab. They actually provide GPUs and TPUs for you. I'm not sure if they provide TPU, but at least they provide GPUs for you, and it's free I think it's free for 12 hours. So it's session based. So you can use their GPU 12 hours at a time. So if you train your model longer than 12 hours, then you'll actually lose all the progress. So hopefully, thankfully, all our practice sessions will be wrapped up within an hour and a half. So that's not a problem. But if you want to do practice on your own and you need to train longer than 12 hours, then you need this Anaconda. So it's a Python, Anaconda is a Python package for data science. So it has all the necessary ingredients for you to train machine learning models and PyTorch models and that. So it includes Jupyter, NumPy, scikit-learn, TensorFlow, PyTorch. So these are the things that you need in this course. Well, not TensorFlow, but the rest of them you'll need them. So you can go to this website and then download it and then install on your laptop, in your computer, in your workstation, wherever. And then you'll be able to practice on your own. If you have GPU for any amount, arbitrary amount of time you want. But as I said, all practice sessions will be conducted in Google Colab. So heads up, when you do your project, you can do your project on Anaconda, but we will assume that you've trained your model on Google Colab and then follow the Google Colab setting when we evaluate. So even if you train your model in Anaconda, make sure that your setting meaning your CUDA versions, your PyTorch version, your NumPy version, your Jupyter version, whatever, is compatible with Google Colab. We'll talk about that later when we actually do a project. Right. So this is the end. Any question before we get to the question? Please join class. I'll talk about this on Calamus. I'll actually leave a notice on the notice board on Calamus, but please do join Classum. And as I said, if you have friends who are unfortunate not to be included in one of the 300 participants, tell them to join Classum. I actually missed some emails, so please do that. All right, any question before we end the class today? 혹시 질문 있으실까요? 제가 영어로 해가지고 혹시 이해가 안 되셨다거나 그런 거 있으시면 한글로 질문하셔도 됩니다. No question. I think this is the first time that there was no question. Okay, there are incoming questions. Will there be office hours? Actually, no. I didn't think of an office hour. If you have a question, you can just shoot me an email anytime you want. Or rather, you can post on Classroom and then I'll attend. But if you want to talk about something personal, something that you don't want to share in Classroom, you can just email me and then we can reserve a meeting time. We can talk anytime on Zoom. So we can schedule a Zoom meeting time. Hope that's so. 유예담님, 네, 답이 되셨는지 모르겠네요. 그러니까 이제 질문 있으시면 클래스홈에 올리든 T한테 뭐 이메일을 던지시든 뭐 저한테 이메일 던지시든 하시면 되고, 개인적으로 하실 얘기가 있으시면 저한테 이메일 보내시면은 이제 뭐 줌으로 시간을 잡아가지고 얘기를 하시면 됩니다. Question from Kim Dong-so. Are we going to have a class on Thursday? Yes, as I already talked about that. So NumPy this week we're gonna do practice on NumPy. As I said, NumPy is a MATLAB in Python. So we're gonna do NumPy this Thursday. Project TUA assignment. There is no assignment other than the projects. 그러니까 이제 프로젝트 외에 점수에 들어간 어사이먼트는 없습니다. 아까 여기 보셨듯이 프로젝트 1 45%, 프로젝트 2 45%, 어텐던스 10%입니다. 그러니까 매주 하는 프랙티스 세션은 그냥 여러분을 위해서 하는 거예요. 그러니까 배우고 싶으시면 스스로 열심히 따라 하셔가지고 복습까지 하셔야지 충분히 이 과목의 가치를 뽑아먹을 수가 있겠죠. All right, all good questions. All good questions. All right, I'm gonna wait 10 seconds before I end the class. How do we check attendance? Good question. So starting next week, we'll provide a Google form where you can just type in your student ID and then we'll collect that and then we'll keep tally as we go on. 구글 폼을 이제 그 링크를 매 수업 시작 때마다 TA 분들이 드릴 거거든요. 그럼 거기 가셔가지고 자기 정보를 입력하시면 됩니다. 다음 주부터요. 이번 주는 안 합니다. Will the grading be judged by yes for the project number 1, which is image synthesis with GAN? Yes, we'll be using FID. Project number 2, translation, we'll be using blue. So we're basically giving all the information you need to achieve a perfect score. 그러니까 이제 저희가 다 그 정보를 뭘로 evaluate 할 거고 뭐 이게 다 드릴 거기 때문에 사실 시간만 들이시면 다 100점을 맞으실 수 있습니다. 근데 항상 신기하게도 그렇진 않더라고요. Will the projects also be so we will provide the skeleton codes, the templates in Python notebook format. You can upload it on Google Colab, you can upload it on the Jupyter Notebook, wherever you want. But the skeleton, the structure or the template, template will be provided in the notebook style. So you can just follow that and then fill in the blanks and then train your model. Right. And if you don't stick to the template, then it'll probably cause error. And then if it doesn't run on the TA's machine, or actually it'll be on Google Colab style, then you will get zero points. So please stick to the format, but we'll talk about that again during the project session. All right. So again, I'm gonna wait. I'm just gonna wait 5 seconds before we end the class. Yeah, don't worry about the projects because the project won't come in another 6 weeks. And when we do give the projects, we'll provide all the details anyway. 네, 더 이상 그럼 질문 없으시면은 이 정도로 마무리하겠습니다. 혹시 질문 있으셔도 클래스홈에 그냥 아무 때나 올리시면 되니까 뭐 너무 부담 갖지 마시고 이렇게 해가지고 사실 훨씬 일찍 끝날 줄 알았는데 꽤 오래 걸렸네요. 좋습니다. 그럼 마지막으로 클래스홈 다 가입하시고 제가 KLMS에도 그 링크 올릴 거니까 다 보시고 가입하시기 바랍니다. 그러면은 이번 주 목요일에 온라인으로 뵙겠습니다. 감사합니다.
지금 감사합니다.
감사합니다.
네, 감사합니다.
감사합니다.